Good morning, this is your Stat Sensei, Mr. Spensei, and this is the pre-quiz, and it's paired data, and we are going to do a confidence interval for drugs for cheap. So, a growing number of employees are trying to hold down the costs that they pay for medical insurance for their employees. As part of this effort, many medical insurance companies are now requiring clients to use generic brand medicines when filling prescriptions. A consumer group wanted to compare the active ingredients in a name brand and its generic counterpart. 10 pharmacies. Well, that right there lets me know that that's probably my sample size. In a large city with more than 100 drugstores, there's a population. We're randomly selected with each store filling prescriptions for both the name brand. And by the way, the word both means something was tested twice. If it's tested twice, that's what makes it paired. All right. So that word right there tells me they're paired. A randomly selected pill from each prescription was selected and the amount of active ingredient was measured. The results are shown on the table and are normally distributed. So we have active ingredient and it was measured in milligrams. All right. So um, what we're requested to do is create a 92% confidence interval for the difference in active ingredient. All right. So we're concerned about the difference in active ingredient. Well, our formula for the paired tea is just almost exactly the same as for a regular tea. With a regular tea, it would be X bar plus or minus T star S divided by square root of N. So this is essentially the same. We just drop some D's on because we're going to talk about the differences. Because we're going to go 245, 244 minus 245 and get negative 1. 244 minus 243 and get positive 1. So we're going to find all these differences. Now we'll do that in just a moment. First, we're going to calculate our T star. All right. Well, to calculate T star, because that's not going to come from the data, we're going to go second vars, inverse T, parenthesis 1 minus 0.92, close the parenthesis and divide by 2. Degrees of freedom. In this case, we have a sample size of 10, so 10 minus 1, because degrees of freedom are always going to be n minus 1 for one sample. And we get 1.9726. Please make it positive, all right? So, which is what I have here. And once again, please remember degrees of freedom is n minus 1. All right, we need to go ahead and calculate this information or calculate the difference. And if I go to stat edit, you can see that I input all that data into column L1 and L2. L1 is generic, L2 is name brand, and the order I put it in does matter. I'm going to go blue 1 minus blue 2, which tells me that I went generic minus name brand, and I came up with these differences. So there's negative 1, there's positive 1, but all the way down. Now I'm going to get my sample statistics. So I'm going to move over to calculate, stat calc, one var stat. The differences were not in L1, they're not in L2, they're in L3. And if you don't have that blue button followed by 3, and there they are. Negative 3.3 is my sample mean. There's my sample standard deviation. And I've recorded that information right here. Negative 3.3 milligrams. All right, sample size of 10 because I have 10 pairs. And this is also in milligrams as well. And then my degrees of freedom, as I mentioned earlier, are in minus 1. Okay, so now that I have that information, I can go ahead and plug that into the formula. I can plug in the negative 3.3 for the X bar, which I've done right here. There's my T star, which came from right here. There's my sample mean, and there's my sample size of 10, the number of pairs. Okay, so what are we doing? Well, we're going to run a confidence interval. So we're going to run a one sample paired T interval. So it's a one sample T interval, but it's really important that you include the word paired if it's paired. All right. So that's what we're going to run. The next thing is we're going to draw what it looks like. Hypothesis tests are always centered on the population mean, but confidence intervals are always centered on the sample mean. So there's X bar. Our X bar was negative 3.3, so we're centered on that. And we have 92% shown here, so 0.92 is in there and 0.08 would be in the tails, not that it asks. So we're going to go ahead and run this test, stat test t interval, and that's what we said we're going to run as a t interval. I want data highlighted because we have data that we put in for stat edit. And then the list I want is in the differences, so make that blue 3 for L3. And I needed a confidence level of 92%. So there's my value, negative 6.285 to negative 0.3148. All right, so this is my lower and this is my upper. So let's just say let's look at this real quickly. So we have generic and we have name brand. I'm just going to pick a number. So 10, well, to make it negative, then this number has to be larger. Well, gosh, 10 minus 12, that makes that negative. That means the name brand has more active ingredients. So the name brand has more active ingredient, and we know that there's a difference because 0 does not lie in the interval. All right. We need to define our parameter. So on our parameter, let mu, and this should have a d, so let mu d equal the true population mean of the differences. Super important that you know that phrase and you use that phrase. You can't just say mean, it's mean of the differences in active ingredients and medication, generic minus name brand. All right, because that's what we did. We're not going to do the conditions. If you want to know the conditions, they're in the previous video where we did the hypothesis test. So our conclusion, we are 92% confident that the true population mean of the differences, there's that phrase again, I keep saying, you got to know it, in active ingredients and medication, generic minus name brand, lies within the interval negative 6.285 to negative 3.485. This is just the interval that we calculated earlier. And this entire statement is right there. All right. It's right there as our parameter. That's a restatement of the parameter. So we need our meaning. In repeated sampling, we expect this method to capture the true population mean of the differences. Still highlighting it. In active ingredients and medication, generic minus name brand 92% of the time. Once again, this part right here is just a restatement of the parameter listed here. All right, I appreciate you watching and look forward to seeing you on the next one. Thank you.